Good day, students. Today we are going to have a bold discussion on this paper that is still fresh from November 2022, Mathematics Paper 2, but yet a serious pandemic because to do it, you have to have the best of the best brains, if not the premium of leadership, precisely because the battle lines were drawn to this paper. Let's check. What are you guys having? Question 4, they are saying that in the diagram, M is the center of the circle having Pn as its diameter. Let's check. They give you the center M. They also give you the diameter Pn. That means M is the midpoint of that line Pn. All right. So you are given the center there and at least the point N, that is 7 and negative 2 in the fourth quadrant. Please get that. KL is a tangent to the circle at that prescribed point N, which is the circumference at the same time, that is 7 and negative 2. Well, they are giving you the tangent KL, which is going to be perpendicular to the radius there, the line from the center M to the circumference there at N, or at that point N there. So you're going to have that situation of the tangents. It's called Theorem 7 in grade 11 mathematics. Let's check what are the questions. Calculate the coordinates of P. Well, you have the midpoint of that line Pn, and you have the point N. How do you then get the P there? So this should be very easy, hence it is given 2 marks. So don't waste so much time here. Let's check question 4. I'm going to write question 4. Well, they gave you everything in here. You just need to accumulate marks. So you are given, let's do it in this way primarily. I prefer to visualize. If you know me, I love to visualize. So check something, guys. You've got the point P, that is X and Y. It's what you're looking for. And you've got the center, that is 3 and negative 5. That is 3 and negative 5. And you also have the point N at the end. So the point here, it's what it's 7 and negative 2. It's what's given there. So let's try to answer 4.1. This one, you don't have to really show it, by the way. What matters is what you have to write here. So you do that just to make sense. So I'm going to use basic maths from grade 10 to say that the x at M is going to be equals to the sum of x at P plus x at Y, at N. Divide this stuff by 2 and say that the same stuff here, but y at M should be equals to the sum of y at P plus y at N. You divide this stuff by 2. Let's check. You have everything. And you are going to get 3 is equals to x at P. So that is x at P plus x at N. That is 7. You divide this stuff by 2. And what is y at M? That is negative 5 is equals to y at P. That is what you're looking for. Plus y at N. And that is negative 7. You divide this stuff by 2. Well, what are you going to get here? You may as well try to give them the x at P here. And that is going to be 6 minus 7. That is negative 1. And then y at P, that is going to be minus 10. And you transpose 2, it becomes positive 2. So it's primarily a negative situation of 8. So therefore, the point P, what they are looking for is negative 1 and negative 8. This is how far I will go with this one. How do you then get the marks here? I think for you to get the right answer and for you to be able to substitute it correctly in that space, that should suffice to 2 marks. Now, let's check 4.2. Okay, what are they saying there in 4.2? They say determine the equation of the 4.2, so that is 4.2. We also have 4.2.1. Determine the equation of the circle in the form of that one. So, okay, you are given the center, that is M. So the center, guys, there, that is at M, and you are given at least 1 point, and you also have that point there. So everything is provided. You can just say that marks is 3 marks. So you are given the center there. So the center is M, that is 3 and -5. So I'm going to say to myself now that this is going to be X at M. So it's a positive. So I'm going to say it's minus 3, and then I have to square that, plus a Y. Y there at M is negative. So I'm going to have a plus 5, and then I square that is equals to the radius squared. Now I need to get the radius squared. There are a bunch of ways in which you can attend this question. The first one will be to take at least 1 point that passes through the circle to get r squared. So we got at least the point n that was given to us. So we can plug this point into the equation to get the r squared. All right. So to do this, we're going to say to ourselves that r squared is equals to, you put the x at n. So the n is still here, that is 7, and y is -2. Let's do that quickly. We're going to get 7 minus 3, and then you square that, plus y is -2, plus 5 there, but you have to square it, and this should suffice to what now? This should suffice to 25. Now, the other alternative, which I may give it to you guys for 3 years, you will say that you need to get your r, right? I'm just going to write or. Your r, what is your r? Your r is primarily the radius of the circle. That is mn. This length here is the radius of the circle and is perpendicular to the tangent KL that is given to you there. So I'm going to say, how about if I find the distance of mn, So I'm going to use the distance formula to do this one. It should be very easy. You are given all the points of mn. So you'll say that n this distance here. So that is primarily, it's really going to be 7 minus 3, and then -2 minus -5. So let's do it quickly. So it's 7 minus 3, then you square that, and then you are going to have what now? Now you are going to get -2 minus -5, so it's plus 5. You square that, and that is going to give you 5 units. All right, so this is the radius. So you are going to place your r in this equation. Let me just really put it here. Let me just have that in that way. So that is your r now is 5, eh? So you can somehow just put it there, like that is 5, and then this will boil down to what we. Let me just say that this is going to be x and then -3. Then you square that, and then y plus 5, and then you square that is equals to 25. So I'm just trying to show you how you get the r squared and how you're going to approach it with r. So what they are looking for primarily, let me just show you what they are looking for from you guys. They are looking for this answer primarily, and to be able to get your r squared, and to be able to, I think this should be given 2 marks, and then that is how you're going to get your r there. They should really give you 1 mark for you there, and everything should boil down to 3 marks. Yeah. That's how you'll go about it to get your r squared. So in actual fact, let me just do it in this way, just right here, to say that, to also emphasize that this one is the second alternative. So what is required from you guys is primarily this answer here, these steps. The first 3 steps, it's what you will do, or you can use the other method, the one that I'm just writing for you here. All right. And yeah, that's it. But most students love the first method. I don't know why, but it makes sense to me as well. It's easy and straightforward. This is how you really go about it. So there you go. You get that 3 marks for that. Should be really easy, guys. Let's check the next question. That is 4.2.2. What are they saying there? Determine the equation of the KL. What is KL? KL is primarily your tangent in the form of y equals to mx plus c. So that is a straight line primarily. How do you then get the gradient of that line, of that tangent primarily? So the tangent is always perpendicular to the radius. So I'm going to say to myself that the gradient of the radius multiplied by the gradient of the tangent, which in this case is KL, is going to amount to -1. So this is a basic maths that you guys should know. The gradient of mn. Let's find it now. That is the radius. The gradient of the radius, that is mn or nm, one of the two. So if you find that, because we are given all the points there, so it's primarily the change in y over the change in x. This is a popular formula. You guys know it by head, I guess. So this will then boil down to y2 of mn. This will be mn there. Just right there. That should be mn or nm. You are given those points. So the change in y over the change in x there is primarily -2 minus -5 over 7 minus 3. So let's pen it down that we are going to get a -2 plus 5 over 7 minus 3. And then what are you going to get there? You are definitely going to get, that is 3 over 4. That is 3 over 4. This is the radius of this is the gradient of the radius, nm. This is the gradient of the nm. Now you want to get the gradient of the tangent. So this will then mean that the gradient of nm multiplied by the gradient of the tangent, which in this case is KL, that is the tangent. Those two gradients, when you multiply them, that should really suffice to -1. And I just want to warn you guys, the other way to write this is to say that the gradient of the radius multiplied by the gradient of the tangent, that should really suffice to -1. So you may write in words, or you may really use letters, just like everything is given in there. You don't have to comment here and say it's wrong, it's wrong, it's wrong. You really love attention, some of you guys. I've noticed that. But I won't entertain you. Now, check. This then means that the gradient of KL, it should be equal to the inverse of that. And that is -4 over 3. So we are looking for the equation of this line, KL. This means that you're going to get y equals to mx plus c, like they really given you there. This becomes a y equals to m. What is m? M is -4 over 3 x plus c. How do you then get the value of c? You have to pick at least one point that line passes through. So the tangent passes through 3 points, that is K, N, and L. But K and L are very useless points at this moment. So you can choose the point N to get the value of C. That is to say that at N, what is N? N is 7 and -2. So I'm going to plug that point there into this equation. Let's see what we get. We get -2 is equals to -4 over 3 into x. X is 7 plus c. Therefore, this is going to give me, let's check that. minus 2, and then a minus, that should become positive now. Yeah, should become positive 4 over 3 into 7. I'm getting a 22 over 3. This is what I'm getting for C. So C is 22 over 3. So this then means that the equation of the tangent is equals to the gradient, which is negative 4 over 3x plus C. But C, you have just found it to be 23 over 3. This is how we should really go about it. It's extremely easy. I don't want to lie to you guys. This is really easy. This is really easy. I just need to emphasize that point, that it's easy. And just for emphasis, for those of you guys who love to comment on my videos, this equation, I'm saying this just for the benefit of your attention. For this equation, it's primarily y minus y1 is equals to m into x minus x1, like that. You can still use that equation, because I know you're going to comment and say, yeah. This really means the same stuff. So please don't comment. It's the same thing. When you use that formula, you are still going to get what I got here if you have a brain power. Let's check the next question here. 4.3. For which values of k will y equals to minus 4 over 3 x plus k be a secant to the circle? Now, this is where you must really structure your thoughts carefully. They are saying that for which values of k will this equation, that is a straight line, which is given by minus 4 thirds of x plus k, be a secant to the circle. So when we say something is a secant, we are talking about such lines. It primarily cuts the circle there, into 2 points. So and if you are to have something like that, that is a chord from Euclidean. I hope you know this term, that this is a chord. But if this chord passes through the center of a circle, it becomes a diameter, But now, if this line now really touches 1 point like that, that really becomes a tangent like KL. Now they are talking about a secant. That means that line must really behave like that. It must cut into 2 equal parts. But I want you guys to see something. They're giving you an equation like y equals to minus 4 over 3x plus k. And I want to warn you again that this equation, or this line rather, it has the same gradient with the tangent. Check the gradient of the tangent. We got minus 4 over 3, which is this particular gradient in here. Check something. This line here has the same gradient with this line of the tangent, but the different thing here is k. It's the y cut of the line. Let me put the other line, primarily this line here. That is y equals to, we got negative 4 over 3 x, and then plus 2 over 3. Think about it, guys. This line is gonna have the y cut at 22 over 3, which is primarily up there. This is where the graph is gonna have the y cut of. Let me just do this carefully there. So this graph is gonna have the y cut just up there. If you are to extend that particular y-axis, think about it now. So the y at that point is 2. This is really 2 over 3. But now, check something. I want to draw another line. Here. And this line should really have the same gradient with this one. Let me really make it a straight line carefully. I just want to be accurate as possible. Now, let me also just show that I'm just extending that line. Now check something here. I'm gonna draw this line now. That is what this is the line there. This line is really parallel. It's really parallel to the tangent line. Let me also really make it a bit bigger there. But yeah, it's fine. Let me have it like with this big. Now check. This line here. It has a different Y cut. It has a different cut with the one that I'm really putting in here. Let me just do this. So we are looking for the values of k for which this blue line here is going to be a second. So it's going to be a second if you check below this y value here. The moment, let me circle it. The moment you go down below that value, this is really going to be a tangent, because think about it. If you are at that point, you are now at the tangent scale. But if you are to go down, you are now playing within the bounds of a second definition. All right. Now think about it. If you are to go less than that value, still going to be below that 2 over 3. So you are still on the second situation. If you go down, you go down, you go down. But think about it. Outside P, it's a line which really doesn't touch a circle. So we were looking for the value of k for which this will be a second. Let me really put it here so that you guys can see something. This line here at point P, it's really going to become a tangent at P. In that way, let me have a tangent at this point. But I'm having a crisis because I don't know the y cut of it, which is primarily going to be at this point here. That's where you should really be concerned, because think about it. The moment you go above that line, that's where you have a second again. So you have to be in between these y values here. So let me show you some magic here. I'm going to find the y-intercept of this line. How do I find that? Remember, we have the point P. We solve the point P to be -1 and -8. They can't just ask you that point for nothing. It will help you to find the y cut of the line. So if I were you, I will say that this is 4 point what now? This is 4.3. 4.3. I'm having the line y equals to -4 over 3 x plus k. How do I find the value of k? I will say at point P, that is -1 and -8. Therefore, let me plug those stuff there. That becomes -8 is equals to -4 over 3 into -1 plus k. Therefore, k is equals to, let's try to really find the value of k there. Well, let's use the calculator. We don't have that much of energy to do that. So this will then suffice to 28 over 3 if you are to type it on your Casio. Now, think about it. It means that this line is really going to be -4 over 3 x plus k, which is -28. We've just solved it to be -28 over 3. So now I'm going to go back. And say that at that point, sorry about that, at this point, the y there is -28 over 3. So I'm looking for the values of k for which this new line there should be a second. I want you to say something. I'm going to move this line again. The moment I go above -28 over 3, that's where I have a tangent. Even if I go above that, the moment I get here, I'm having a tangent. So I must be in between this y value of what? Of -28 over 3 and 22 over 3, the y cut of the lines. All right. So that's how we should really plate. This line should really be in between here in order for it to be a second. And that means it has to be in between negative 28 over 3 and 22 over 3. All right. You know, or you can say that K should really be less than 22 over 3, but bigger than negative 28 over 3. So this is how you will pen it down. Check. This is how you're going to pen it down, that the K should be less than but exclusive, because if you include it, you're going to be a tangent. It's going to be 22 over 3. That should be bigger than now, negative 28 over 3. K should be bigger than negative 28 over 3, but less of that y cut of that tangent line, the main one. All right, I will say the main one because it's what it was given to you. So this is how you really get it. It was really having, how many marks was this situation having? Let's check. This was 4 marks. So this was 4 marks. Where do you really get the marks? Even this one was really having 5 marks. So you must be able to get the right answer there and get that one. You know, that makes to be 2 marks now. That should really be, you should be able to do that. That is 3 marks. And get the gradient of Mn and be able to really do it in that way. You know, that's really 5 marks for you guys. Now, with this one, they should really give you some nice marks there for you. And to be able to get the equation correctly, you know, to be able to get that equation correctly and also the value of K, that should then suffice to 4 marks. All right. Let's check now. What are we having? 4.4 now. Let's go to 4.4. 4.4. What is the story there? So I may as well need to erase this work here. I was just trying to make a general emphasis there. They say that points A, which is T and T there, and B are not shown on the diagram. All right, so these points are not shown in the diagram. From point A, another tangent is drawn to touch the circle with the center M at point B. Check something here. They say that the points A and B are not shown on the diagram, but from point A, another tangent is drawn to the circle with the center M. This drawn to this circle primarily, just this circle, from point A, but the tangent now is at B. So think about it, guys. I can say to myself, if now I have a point A, let's first have a tangent at B there. Let's call it a point B in here. Let me make it a tangent, you know. From that point, let's say that is a tangent there. Let me really make it a proper tangent. Yeah, I think now it's a proper tangent. So we are saying that there is a point from A, you know, a point from A where A is what now? This is T and T as well. This is a point T and T. Okay, a point T and T there. And then B is a tangent, you know, at that point, B. So any line drawn from the center to the point of to the circumference is primarily a radius. So this radius to the tangent, these are going to be 90 degrees. Think about it now. If now I'm to construct a certain line like that, this really makes a triangle of 90 degrees. Or you can say to yourself, let me draw it for you. You can say to yourself that let's have a point A somewhere there, and then a point B here. I'm going to make it a tangent. like that. And then now I have a radius there. So this is going to be perpendicular to each other. What are they saying? They are saying that show that the length of the tangent AB is given by the square root of 2t squared plus 4t plus 9. So you can use this argument, any line from A, you know. So I'm just going to do it in this way. So what are you looking for? You're looking for AB. So this is M. Primarily here it's M. And then what are you looking for again? So that the length of AB, this length here is what now? That length is that square root of t squared plus 4t. So what is this length of MB? You have to find it. But this is a radius of the circle. And we got that to be 5 back ago. You know, so that is 5. Remember, any line from the center to, you know, the circumference of the circle is defined as a radius. So I'm looking for the AB, that distance. But this is my hypotenuse, eh? So I can use the Pythagoras theorem. That's why it's 2 marks. You must use Pythagoras theorem. Let me just do this. I actually need to redraw this, but I don't have to. I really don't have to. Let me just, in fact, redraw it, that side, because I love analysis. So you have this situation primarily here. Let me really draw it a proper triangle. Okay. So this is my analysis here. This is a point M, the center. That is, the center is what now? I forgot the center, eh? I've been doing this thing. Is 3 and negative 5. So this is 3 and negative 5. This is 3 and negative 5. And then the point B, the point B is even useless. That is XY, because you have the radius there. You know, you won't even use it. So this is the point A. The point A is it's T and T. So how about if you use Pythagoras theorem here to say that therefore AB squared plus AB squared plus MB plus MB squared, this must really give you AM squared, eh? This will give you AM squared. What is that? You must just write that this is Pythagoras theorem. Now let's substitute AB. AB is what you're looking for apparently. So you're going to have AB squared and then plus MB. MB is 5 units there. It's really this distance is equals to AM. What is AM? That distance is primarily going to be T minus 3. You square that and then plus T minus 5. So it's plus 5 all squared. Now, let's see, what are you going to get? You're going to get AB squared plus 25 is equals to T squared minus, this will be minus, this should be negative 6T. My goodness. Plus T squared plus 10T plus 25. So AB squared should really give you, let's group all the like terms together. Let me transpose also 25. So this becomes a 2t squared. And then this 25 and this 25 are going to undo each other. So I'm going to be left with minus 6t plus 10t. That should suffice to plus 4t. And I'm left with a constant of 9. Therefore, the distance AB is going to be the square root there of this situation. That is 2t squared plus 4t plus 9. So that is what you are required to prove here. This is what you are required to prove. Someone would comment and say it's wrong. Yazin, my goodness. But It's clowns, who lacks educational background. Now you will say that what did they say here? Show that the length of the tangent AB is given by that. So you can just waste time again, say that therefore the length of AB, of the tangent AB, okay, of the tangent AB is given by, you can just copy this work here and put it here. This is how you really go about it, and let's see where will you get the marks here. You will get it from Pythagoras formula there, to put it nicely, and also they will really observe what you are doing there, because if you can plug this, you can't really get it wrong if you've got the brain power. So I think the marks will really come from there. That makes it to be 2 marks, you know, in my own sense. So now they give you 4 marks again. They say determine the minimum length of AB. How do you then get the minimum length? This question really boils down to paper 1 arguments. Your question 9, the minimum length of AB. How do you then get the minimum length? I think it's that question really that caused a lot of crisis. It's 4.4. This was 4.4, 4.1. Okay. Let me number it properly. This is 4.4. This is 4.4.1. We are now at 4.4.2. We want to get the minimum length of this one. How do you then get the minimum length of that stuff? We agreed that we had AB squared is equals to 2t squared plus 4t plus 9. You know, this is a function of t. You know, think about it. When they say it's a minimum length, I need to clarify this, because I saw a lot of crisis from a lot of you guys jungling. When they say a minimum distance, this is now a function of t. Think about it. This is AB squared. It's a function of t. It really becomes a function of t. And you are getting t squared plus 4t plus 9. If you are to sketch this situation, you will see that you are definitely going to get a situation which behaves like this. I know this is paper 2, but I'm really trying to show you maths here. This is going to be the minimum length because of the value of A is positive in there. If that value of A was negative, they will have said calculate the maximum length, because this will have behaved differently, and this will be the case of the behavior. So at this point, that's where you are really going to have the maximum situation, you know, which is the length in this particular argument. So how do you then get the maximum and the minimum of a particular polynomial? You have to really get the first derivative and equate that to 0. So I will say to myself that therefore this is dAB squared, you know, divided by dt. This would give me 0. That's where the minimum situation is going to occur, you know. There are myriad of ways to do this problem, by the way. This is my approach. And this will be 4t plus 4 is equals to 0. And therefore, your t should give you -1. But hey, think about it. You are looking for the minimum distance of AB. So I'm going to really take my equation AB and plug t as 1 there. And this will suffice to the minimum length they are talking about. So this is 2 -1 squared plus 4 of -1 plus 9. And then this will really boil down to, let's check. you get a 2, you get a -4, you get a +9. And as a result, this will really be -2. You're going to get a -2 plus 9. So it's primarily 7 units. This is the distance. Or you can round it off to 2 decimal places to say that you're going to get a 2,65 units. And thank you very much for watching. This is how far I'll go with this question. The next video I'll make trigonometric functions. I'm gonna do this trick. I wanted to do it today, but I don't want to make long videos. So I want you guys to watch properly. So I'm gonna make it tonight, later. So even this one, I'm gonna make these 2 in one video because they won't really take that much of the time. Yeah, thank you very much for watching. See you next time.